Alright, today we want to do a little bit with the application process of linear equations. So right here I've got an example of a linear equation, or a story problem that we're going to try to model with a linear equation. So I read through this. Lynn is tracking the progress of her plant's growth. Today the plant is 5 centimeters high. The plant grows at 1 5/10 centimeters per day. Okay, so before I even get into the question, something that's very important to me right there is that I see that I've got this 1 5/10 centimeters per day, and what that does is it tells me that it's a constant rate of change. That's kind of important, because if it's a constant rate of change, that's how I know that it's linear. So it's continuously changing at the same amount each day. And the other thing that happens with that constant rate of change is it's our slope. Well, that made that nice and easy. Now I look at right here, here's our starting value, 5 centimeters. So no time has gone by, and it's 5 centimeters tall. So that means that's actually our y-intercept. So if I think of in the context of the story problem, y equals mx plus b, our slope-intercept form, well, here's our rate of change, our slope, and here's our start value. So if I look at part A here, write a linear model that represents the height of the plant after d days. Well, I'm going to have to change around some variables here, because I need height and date. So instead I might be thinking the height is equal to my slope, goes in for m, 1 5/10. Instead of x, we're going to use d for number of days, plus our starting height, 5 centimeters. There we go. That wasn't so bad. Now for part B, well, what do we do with that? The height of the plant after 20 days. Well, it's 20 days. That means D is equal to 20. So the height has to be equal to 1 5/10 times 20 plus 5. Let's see, 1 5/10 times 20 is 30, plus 5, 35 centimeters. We know the plant is going to be 35 centimeters after 20 days.